Problem B3. The positive integers from 1 to n, where n is greater than or equal to 2, inclusive, are to be equally spaced around the circumference of a circle, so that A. No two even numbers are adjacent, B. No two odd numbers are adjacent, C. No two numbers differing by 1 are adjacent. What is the smallest value of n for which the above is possible? Now, to look at this, we can first try 2, and immediately we can see that 2 is not possible. 1, 2, table or circle. I like to imagine it as a table. This is not possible. They are differing by 1, so 2 is not possible. Therefore, for any arrangement, the number 3 has to appear. Now, the only possible values that 3 can be next to, so if you have like 3 here around this circle, and then what goes here, the only possible values are 6 and 8. Those are the only possible values. There's no other ones. So we find that since it's 6 and 8, we find that n has to be greater than or equal to 8, because 8 is one next to 3, one of them next to 3, and it has to be at least 8, otherwise 3 won't appear. So from this, we can now just try 8 and see if it works and keep going up. This is the circle. Let's start with like 1. What can be next to it? Let's say a 4. Next to 4, maybe 7. And next to that, we could go for like a 2 and then a 5, I would say. After 5, we can go for like a 6, no, an 8, yes. And now it's the 3, and then this is of course have to be a 6. See, 3 is next to 6 and 8. And now actually we found a working pattern. We can check no numbers differ by 1 next to each other, and also no numbers of the same parity are next to each other. Therefore, the solution is n is equal to 8 is the smallest possible value.